Welcome to KB.TV, the channel with a difference.
What's up, y'all? It's your boy King Bryan for real. Keep it locked. King Bryan for real. Keep it locked.
Hey guys, welcome to this section of the video where we try to summarize everything that we've learned in the earlier part and try and solve some problem. Now, but in this video we don't have a problem set, but what I'm going to do is I'm going to go through all the problems that we had early in the video and let you get a more one-on-one as to how we did what we did. So basically, in the first part of the video we had where we find for u when we had addition sign, when we had how we deal with it when we subtracting, when we have a quotient, when we have a product. We also had some removing of brackets, some removing of powers, when we had to do a little factorization, and also when we had to do some substitution. Now, I will just go through that quickly for you. So, let's get started. So, the first one, number one, we had v is equals to u plus t. Pretty simple. Now what are we finding for? Finding for u. Okay, let's go. So basically what we're doing is taking everything away from u, leaving the u standing on this side alone. So we have plus t. So when we're moving a plus sign to the other side of the equal sign, what basically happens is that it is the opposite of what it is on the said side. So basically this is simple. So finding for u, what basically we do, we take this t over, which it will then change to subtract. So we have v minus t is equals to u. And that's it. Pretty simple, huh? Alright, let's see what we would do with the second one. The second one, we have v is equals to u minus t. Now, this, same finding for u. Same finding for u. Now, basically what we do, finding for u, we taking this minus t and bring it across equal sign. So that therefore will give us v plus t is equals to u. There goes. Pretty simple, huh? Alright, we're going through a pretty simple topic. Even though at times it get a little tricky, but once you understand the main principles and you take your time and apply it, there's no problem. So let's go. We have v divided by t is equals to u. And in this case, we're finding, or what we're finding for? We're finding for v. Alright, what are we gonna do here? So we have a quotient. What basically we do, take this little bad boy here, carry it across to join the soldiers. So what we have, it is dividing on one side, it do the opposite on the other. So if it is dividing, when it go over, it multiplies. So basically that gives us v is equals to, what is it? U times t, which can be rewritten as v is equals to ut. That's it. It's pretty simple, straightforward. Alright, so the fourth one on the list was v is equals to ut, and they asked us to find for u. Alright, so let's go. We're finding for u. The t there, it's a product and it's multiplying, so taking the t to the other side of the equal sign, what happens? It divides. So basically what we have is v divided by t is equals to u. There we go. So when you're adding, you subtract on the other side of the equal sign. When you're subtracting and you're moving over, you add. When you're quotient and you're dividing and you're moving over, you multiply. And once you're multiplying and you move over, you divide. Okay, pretty good. So let's move on to a little more, not so tricky, but let's see what will happen. Number 5 on our list, and that is Alright, let's give it a try. Alright, so we know that we have to remove this bracket somehow. Everything have to cancel out and leave us with x alone. How is that possible? Alright, let's start putting down some stuff and see where it leads. So this is the same as, okay, this implies, what we got? What we can get from this? Have x, we know the square root. If we know the square root is the same as a half, we put that back 2. We're heading somewhere. Therefore, if we drop this bracket, we see clearly that these two powers are multiplying based on laws of indices. Equals to x a half times 2. Pretty simple, huh? So basically this, okay, let's look at it. Let's just open a new window here and see what's up. Alright, if what we will do here, we have half times 2. 2 is the same as 2 upon 1. So what we do is, if we have to multiply something like this, we can go right ahead, we can cancel out, or we can just multiply and simplify. So alright, let me show you the first way. The first way, you can cancel out 2 1s 2, 2 1s 2. So you have 1 times 1 is 1, 1 times 1 is 1, 1 upon 1 is 1. That's one way. And the second way is, we have an half times 2 upon 1. The second way, what we can do is just multiply it and cancel out at the end. So 1 times 2, 2, 2 times 1 is 2, 2 upon 2 is the same as 1. So, you see clearly what's happening there. So we close our little window and we continue the problem. So we know that half times 2 gives us 1. So this is our justification as to how we end up with 1. Yeah, we know if we have 2 halves and we put them together, we get a whole, which is 1. But you still have to show some calculation to back that up, and that's it there. Alright, good. So we have x to the 1. And x to the 1 can be rewritten as x. So there goes. We remove the bracket and we find x. Pretty simple, huh? So let's go that back. Remove the bracket and find for x. This is the function they give us. The first thing we do, we know that the square root of x is the same as x to the half. And we're removing the brackets, so we know once there is 2 powers, they multiply each other. Once they multiply each other, we have some solution. In this case, we can see clearly that we have a half times 2, which is 1, because 2 halves is a whole. So 1, and anything to the 1 power can just be rewritten as the said. So there goes. Number 5. Moving along to lucky number 6. How can we take an x squared and just end up with x? So basically what that implies, we have x squared. Now we're trying to get rid of that x squared. What do we do? What do we do? What do we do to get rid of a square? Basically, to get rid of a square, we would raise to the half power, because we know the 2 powers would multiply and cancel out. So basically what I'm saying, is we will have x squared to the half. This then would give us x to the 2 times a half. And we know this would be x to the 1. And this would be x. So there it is. Find the power over x. You have x squared. X squared we raise to the half. The 2 powers multiply out, give us a value. And there it is. So yes, number 7. We have V is equal to R, 3R divided by R minus R, making capital R the subject of the formula. So now what we do, we have a quotient, so first thing we do is transpose. So we have V multiplied by R minus R is equals to 3R. So what will be the next step? The next step will be to simplify this. So in this case, what we have? You have V times R which is VR minus V times R. What do we have? A minus VR is equals to 3R. Alright, looking good so far. So the next step basically would be, since we're finding for R, is to group these on the same side. I want to take this across and bring this across. So let's go. We have VR is equals to 3R plus VR. Bringing the negative across, we add. So now we're taking this over. So we will have VR minus 3R is equals to VR. So we have these two on the same side. So basically what next is we see that R and R is common between these two, so we then factor it out. So what we do, what does that mean? We have R times V minus 3 is equals to VR. If we simplify this, we'll end up with this. We have R times V is VR, R times 3 is 3R. Okay, good. Moving along nicely. So we're finding for R. So basically what we do, we take this cross equal sign, leaving R alone. We have a product here, so when we go over, we will have a quotient. So that basically tells us R is equals to VR divided by V minus 3. So that's it. This is our solution. Alright, let's run that back. V is equals to 3R divided by R minus R. Finding for capital R. First thing we do, we change this from a quotient, take that up. When we take that up, it turns a product. Next thing we do, we simplify this. Simplify it up, multiply the brackets, V times R is VR, V times R is minus VR times 3R. Then what we do next, we try to group these capital R, since it's R we're finding for. So we group them, we transpose and we group them. We see that R common here, so we factor it out. We form a product, finding for R. So it's a product here, we take this over, we have a quotient. Pretty simple. Moving along to lucky number 8. Looks a bit different. Let's go. So we write back our function. V is equals to U plus AT. But we know these values, so we substitute them. So we know V is 18 equals to U, which is 5, plus A, which is 2, multiplied by T. So then now we're finding for T. So let's start transposing. We have 8, we're taking everything away from T, leaving T by itself, starting with the 5. So you have 18 minus 5, since it's positive on this side, is equals to 2T. Alright, 18 minus 5 is 13. 13 is equals to 2T. So what's next? What's next? What's next? What's next? Come on, anybody? What's next? What's next? What's next? The next step is to get rid of the 2 from the T. So basically it's a product here. When it comes over, we have 13 divided by 2 is equals to T. And we also know that this could be broken down further. So we know 2 6s, 12, and 1 is 13. So that is equals to D. So we know 2 6s is 12 and 1 is 13. So therefore T is equals to 13 upon 2 or 6.5. Do remember to like, share, and subscribe for more. This is your boy King Bryan saying, I'm out.
Took my heart away from money, I ain't interested in fame, and I pray that never change. Ambition is priceless, it's something